if I want to graph this, let's first think about what the story is behind this equation. Here's the story. The story is I began with 2 and I'm tripling x times. So I'm beginning with 2 and I'm tripling. So if I begin with 2, doesn't that mean my first initial value is 2? So what that means is I could put a dot here at 2. I start at time 0. At x equals 0, I get 2. Now you could also kind of figure that out just by making a quick table. If you kind of make a quick table, you could make sense. If I just took 2 values in, could you technically put 0 in there? And can you tell that be 2? Or could you trust me or remember that with exponents, isn't that first number always what you start with, your initial value, your value at 0? And the second number tells you how it's growing or shrinking. And if you're tripling, aren't you growing? So what do you get if you triple 2? Isn't that 6? So what happens is, at 1, you're going to get 6. Because one time, if I triple 2 once, doesn't that give me 6? What if you tripled it again? What do you get when you triple 6? Isn't that 18? Is that off the graph? So I'm starting with 2 and I'm tripling once. Now, could you go over here and put in 1 and see it 6? Do you see how the table could do it too, right? Yeah, you could always make a table to graph, always. But I want you to more understand what's happening. That's what's important. I want you to understand you're starting with 2 and you're tripling. Now the graph looks like this. Here's what the graph ends up looking like. There's an asymptote. The x-axis is your asymptote. And it looks, I call it a skateboard ramp. If you've been on a skateboard ramp, you see it kind of looks like that. Look, if you're like really kind of a half pike or something. But there you go, boom. It's called exponential growth. Starting at 2 and tripling over and over. It's very steep. Now, the question we really care about is what's your y-intercept and your rate? That's the kind of questions I more ask. So let's talk about y-intercept and rate. Well, isn't that your y-intercept right there? So my y-intercept, I call it y-int, is just the 2. That's always the y-intercept until you start shifting it. When shifting comes, it messes it up. But for now, that's the y-intercept, that front number. Boom. Or plug in 0. That's your y-intercept. Plug in 0. Okay, now the second question besides the y-intercept is I want to know the rate. Well, we are tripling, but what's the rate? Well, the rate, what we've learned is the rate is always 1 plus something gives you your rate. So your rate is always 1 plus something. Now in this situation, isn't it equaling 3? So 1 plus what number would give me that number? Wouldn't that be 2? So wouldn't this be a 2 right here? So what percent is 2? Is that 2%? 20%? 2 is 200%. So what my rate is equal to a positive 200%. Meaning this graph is growing by 200% each time. 200% of 2 is 4, so I added 4. That's what's happening. You're adding 200% each time. 200% of 2 is 4, and that's why we're up here at 6. Now, that's kind of confusing with the 200%. But just understand, you're going 1 plus what gives you this number. And that will be your rate. Now, why is it positive? It's because you're adding. If that number was less than 1, your rate would be negative. So recap. Y-intercept is the first number, and 1 plus what gives you this is your rate. So that's your y-intercept, and that finds your rate. It's not is your rate, that helps you get your rate on an exponential problem. And then your graph always has a y. This y-axis is your asymptote, and it goes whoosh, up. Now for this problem, I have a negative x power. That's a little tricky. I'm going to rewrite it with the negative power. Watch what happens. I'm going to rewrite this function as y equals 10, 2 to the negative first to the x. I am allowed to take the negative off that and bring it inside with the 2. Because when you take a power to a power, that becomes a negative x, which takes us back to our original. Basically, that might confuse you. Basically, if you have a negative on the x, bring it inside. And then, what is 2 to the negative first? Hopefully you remember, 2 to the negative first means 1 over 2 to the first, which is 1 over 2. So this is the same as this. And this is a whole lot easier to understand. That negative x power really messes things up. So you want to change that to 2 to the negative first, which is 1 over 2. So this right here is what I want to look at and find my initial value, my rate, sketch it real quick. Now, since this value is less than 1, it's going to be decaying. This value is your y-intercept. So, like we said earlier, what is my y-intercept? It is that number right there, 10. So put a 10 right here, dot at 10. So the number in front of your y-intercept, this right here is how you find your rate. So 1/2. To find my rate is going to be 1 minus what equals 1/2. Now you might wonder why I put minus, why not plus? Well, isn't that smaller than 1? So don't have to subtract something to get 1/2. So 1 minus what will give me this right here? Well, what decimal would that be? It's 0.5. Isn't 1 minus 50 cents a $0.50? So my rate is 0.5, which, what is that in as percent? My rate is 50, my rate is equal to negative 50%. The reason for negative is we are shrinking. See the minus there? We're shrinking by 50% over and over again. So my y-intercept is 10, and I'm shrinking by 50% repeatedly. Well, isn't that the same as halving? If I halve something, don't I shrink by 50%? So what is 50% of 10? 5. Or what is half of 10? 5. So wouldn't my next dot be 5 here? And then if half of that, wouldn't that be 2.5? Half of that, 1.25. Could you keep going? Can you see this graph right here? It's called exponential, but it's going the opposite direction. Will it ever touch the x-axis? If I keep halving and halving and halving, will I always have a little bit left? Do you kind of see? This is called exponential growth. This is a decay. See how we're decaying but never hitting 0? If you have a positive rate, it looks like this. If you have a negative rate, it looks like this. The first value is where you started. That's the key. The value in front is where you start. This and this tell you how you're changing. If it's less than 1, you're shrinking, creating a negative rate. If it's greater than 1, that is how you're growing. And that's the key. Could I make a table to graph this? Could I plug in 0 and 1 like here and graph it? Yeah. But we're trying to more see the idea of what's behind it. For this particular graph, you got a lot of weird stuff going on. You have a negative 2 beginning value, but won't the plus 3 shift that up 3? So let's think about that. My y-intercept is normally negative 2, right? But what will the plus 3 do? Won't the plus 3 here push that up 3? So my y-intercept is actually going to be 1. That might bug you a little bit. But what I did, that normally is my y-intercept, but wasn't that pushed up 3? So now my y-intercept is 1. So I got a y-intercept right there at 1. So we actually began at 1 and not at negative 2. That k value really kind of makes it more complicated. All right, next, what's my rate? Well, isn't the rate, since there's an e here, isn't your rate going to be up in the exponent? Isn't your rate right there? What number is in front of the x? Nothing. So wouldn't there be a 1 in front of the x? So what's 1 as the percent? Isn't my rate going to be positive 100%? Aren't we growing at 100%? So what I have here is a graph that starts at 1 and is growing by 100%, but it's growing upside down. Isn't negative mean upside down? So watch, this is a quick sketch. Watch this. Normally, wouldn't it look like that? But, with the asymptote here, but since it's negative, isn't it going to flip and look like that? So the red is what you're getting. Normally a growth looks like this, but this one's going to be flipped and down. That's kind of interesting. Normally, wouldn't your asymptote be the x-axis? Wasn't that shifted up 3? So isn't your asymptote now right there? Isn't your asymptote right there? Now watch. Your graph will look something like this. Could I plug in values? Could I plug in 1 or 2 to find what values there are on this graph? Yeah. But in general, can you tell your asymptote will be there because it got pushed up 3? Can you tell your y-intercept's there? Can you tell it's an upside down growth looking like that? That's good enough. That's all you got to know. You got to know the basic look of it. If you want exact, could you plug in numbers? Yeah. Again, the front number's where you started, but the 3 pushed it up. That's why it's 1. The power on the, right there next to the x is your rate, so it's growing by 100%. Now this is a 100% continuously compounding, but E has some different properties. And that negative in front really kind of messes things up, make things a little bit more complicated. So for this last graph here, first thing I want to do is look, where would my asymptote be? It's normally going to be right here, but because of this -7 down, my asymptote would be down here at -7. All right, my y-intercept would normally be 3, but for these problems, we want our y-intercept. But for this one, it normally would be 3, but don't we take this 7 and subtract from it? So my y-intercept is now -4 because it was 3 and it got pushed down 7 values. So it is now at -4. So that right there is my new y-intercept. Which, interesting enough, isn't that y-intercept 3 values above the asymptote? Isn't that tell you how far it is above the asymptote? It kind of always works that way. Your front value is always how far it is above the asymptote. So if the asymptote got moved, so did that value. So 3 above. Next, that negative power, what's that going to do to us? Well, that negative power means this. This is really 3 in front. I flip 1/4 and it's a 4. That's really the function. I don't like negative powers. The moment you have a negative power, change it. And this is what we're really graphing. The negative power really screws it all up. So, what is my rate? What is growing? My rate is going to be, well, let's think. For my rate, it's 1 plus what gives you 4. 1 plus what gives you 4? Can you tell that's a 3? So my rate equals a positive 300% growth. So that's my rate. That was my y-intercept. So a positive 300% growth. Now, I'm not going to worry about the exact value. All I know is it's here and is growing very drastically. So it looks like a skateboard ramp. So it's going to go like this, and it's going to grow extremely rapidly. Now, could I find the exact value of the next value? Yeah. Could I technically put 1 right there? 4 to the first is 4. 12 minus 7 is 5. So really, I really jacked. It should have been way up here. Technically, there was a dot there. But I just want to basically know it goes like this and steeply grows at a 300% rate. Don't forget, negative powers, flip it. This is the graph you want to really look at. And also don't forget, that was your y-intercept, but that pushed it down. It's 3 above the asymptote.